Hello, exceptional 8th graders and stunning 7th graders of MSM3. Today's lesson is on the distance formula. The distance formula is actually derived from and based on the Pythagorean theorem, which you've spent a few days practicing and learning about. The beginning part of these notes is going to show you where the distance formula comes from. How it's derived from the Pythagorean theorem. And then the second half of this lesson will show you how to use it and examples of how it works. So let's get started here. We need to find the distance between these 2 points. Now, if it was a horizontal or a vertical line, I could just count to find that distance. But since it is diagonal, I can't do that. So that's the distance we are trying to find. So let's take a look here. I was already kind of showing you this horizontal and vertical distance, and I've now just created a right triangle, and we know how that works. So let's look. 1, 2, 3, 4. That has a length of 4 units, and then this has a length of 3 units. And we know, using the Pythagorean theorem, we could figure out what this distance is. So I'm going to do 4 squared for A plus 3 squared equals C squared. And we're just going to call this D. I'm going to plug that D for distance. So that would be D squared. So we get 16 plus 9 equals D squared. So 25 equals D squared. And square root each side. So we get a distance of 5 units. Okay, so that's just using the Pythagorean theorem and being able to count the distances for the legs. Now, you may not always have the coordinate plane. You may not always have this option. So if you just have the 2 ordered pairs, that's where the distance formula will come into play. So let's look at that. Let's look at these 2 ordered pairs. This first ordered pair is at 2, 4, and then this ordered pair is at 6, 7. So where did the 4 come from? Well, if the 4 for A squared, or for A. So if I look here, this x value is 2, this is 6. Well, how do I get 4 from 2 and 6? I find the difference between them. 6 minus 2 is 4. So I just took my 2 x values and I subtracted them, okay? So let's see, make sure you can see everything. So I took my 2 x values and I subtracted them. Now this notation should look familiar. Remember the 1 and the 2, they have no value. They're for labeling purposes. They're not exponents, they're down below. They're called subscripts, okay? So this right here, doing x2 minus x1, that represents the 4, which is my value for A. And what do I have to do once I have A? I have to square it, okay? So then plus, so now we're going to figure out where did the 3 come from for the B? And I bet some of you are already thinking, well, that comes from the Y values. What did we do to go from this Y value to this Y value? 7 minus 4 gives me the 3. So I took my 2 y values and I subtracted them, and that gives me the 3. Now, once I have the 3, what do I have to do? I have to square it. So x2 minus x1 squared plus y2 minus y1 squared, that is all going to equal your distance squared, right? D, we substituted in for C. D is our hypotenuse. So that looks pretty complicated, but hopefully that makes sense. But we're trying to find the distance. We don't want the distance squared. We don't want D squared. We want D. So in order to get D alone, what do? I square root it. Well, remember, when I'm solving equations, what you do to one side, you have to do the same thing to the other. So I'm going to take the square root of each side. So that leaves me with D. So D equals, Unfortunately, there's nothing more I can do to simplify this any further. The square root does not cancel out these squares because we've got this little plus sign here. I can't do anything with the squaring until I do this subtraction inside the parentheses. All those order of operation things are keeping me from simplifying this any further. So that right there, this big long piece, that is the distance formula. And there it is. Comes from the Pythagorean theorem. So let's flip over and we're going to use that formula. Now I can hear, I know none of you are here right now, which I'm so sad about, but I can hear the moans and the groans already about this formula. Sorry, that is just the way it is. Yes, you need to learn it. Yes, you need to use it. And yes, just like with every other formula, you must write it every single time that you use it, which will be a good thing because since it's so long, it will make it easier for you to learn it and remember it. So D equals, write out that formula. It's right up at the top of the page there, in case you forgot. Hopefully you'll get to a point that you don't forget it. Okay, so we got to figure out what's x1 and what's x2 and so on. Do just like we did when we were doing the slope formula and just label them ahead of time. It'll help you keep track of things. And again, it doesn't matter which is which. You just can't mix and match, x1 with y2. You got to keep the ones together and the twos together. So I've labeled them. Let's substitute in. Let's see, x2 I said was 5 minus 1. We'll square that, plus y2, 6 minus 3. I'll erase that. It's a little messy. 6 minus 3 squared. So now we start simplifying. Follow those order of operations. I can't square until I've done inside those parentheses. So 5 minus 1 is 4, so 4 squared. 6 minus 3 is 3. So 3 squared. Again, I can't square root yet. I've got this plus sign. I have to do the exponents before I can take that square root. I have to do the exponents and then add before I can take the square root. So 16 plus 9. So D equals the square root of 25, which is nice and friendly, and we get 5 units. Now, they're not all nice and friendly. You'll see that in the next one we do, but this one does happen to be. We know that when it's nice and friendly, it's a nice perfect square there. I know a lot of you are probably, thinking, wow, that's a lot of work. Why do I have to show all these lines? It will just help keep you organized so that you don't make any silly computational mistakes and you don't make any silly mistakes with order of operations. So you want to be very careful of that. And let's do the next one. So again, write that formula and stop complaining as you're writing it. I can still hear you all. There we go. So there's your formula. So D equals, all right, before I start substituting in, let's label things. All right, so x2 I just labeled as -2 minus 1, which will get squared, plus y2 is -4 minus 5, which gets squared. Hopefully you're all set with your integers. -2 minus 1 is really -2 plus -1, so that's -3. You've got to make sure you put the -3 in parentheses. If you don't, if you write it like this, that means something completely different than that. I need to square -3. In order to square -3, I need the -3 in parentheses. So be careful of your notation. And then -4 minus 5 is -4 plus -5 or -9. Again, make sure you have those parentheses. So 9 plus 81. We get the square root of 89. And this one's not a perfect square. It's not friendly at all. You'll need to get out your handy-dandy calculator. Yes, you can use a calculator on this assignment. So do the square root of 89. Oh, Mistake. Oh my goodness. Can't add. All right. Now you're all laughing at me. That's all right. I can handle it. So try again. Square root of 90. Get that handy dandy calculator out. Square root of 90. It's an irrational number. It's not a perfect square. That means it keeps going forever and ever. So we're going to round it to 2 places. So that would be 9.49 units. And I can hear you all screaming at me right now that it's not equal. It is about. So about 9.49 units. There is one more problem left on this note sheet. I'm not going to do it in the video. It's the same thing. It's the same process over and over again, but it is filled out in the notes that are posted in Google Classroom. So if you've got any questions, if you're unsure, make sure you contact your teacher, and you know, we will be certainly doing our best to help you out with this. So I hope you have a fantastic day. Hope to see you soon. Have a good one.